Well, a very warm welcome to everybody who's managed to take time out today and join us for lunch in this, our third and final week of this Bite-Sized Corrosion series, where we've been looking at pipeline coatings. During this series, as we've talked about pipeline coatings, we've really been trying to help to give a little bit of background and perhaps some guidance as to what are the benefits and disadvantages of the various specific coating groups that we have spoken about, so that you're making more of an educated guess and not necessarily just driven by the most eloquent salesman. We spent some time looking at the polyethylene coatings and epoxy coatings. We looked at polyurethanes, we looked at polymer modified bitumen, and the links to all of those discussions are available on both our Teachable platform as well as our website. So you're welcome to catch up if you were unable to join us. Today we're going to hone in, as it were, looking at tapes. Now we're all familiar with tapes. We all know sticky tape, for example. I think that's the most common tape, except it's least common on Christmas Eve after the shops have closed when it runs out. Now, perhaps the most famous tape is in fact duct tape, because that's the one that was used to do the emergency fix in space on the Apollo 13, where, if you recall, some of you are old enough to have listened in. Some of us are a bit younger than that and have read it in the history books, but where the astronauts fashioned an air filtration canister to remove carbon dioxide. And they used surplus materials, bits of cardboard, paper, and duct tape holding it all together. Now, other common tapes have a far less interesting history. Things like insulating tape, which you should find in the toolbox of any self-respecting electrician, and double-sided tape, perhaps. Be careful using that if you do want your mirror to really stick to the wall. And even plumber's tape, or also known as Teflon tape.
Just be careful with that one. Although plumber's tape is related to pipes, it's not necessarily the right kind of tape to use. This little illustration shows you that plumber's tape was used in lieu of a proper insulating sleeve for an insulating flange installation. And needless to say, it didn't provide its intended function of insulation, because plumber's tape is intended for effectively sealing and lubrication. The other example of what not to do is, I think last time you were talking about bituminous felt. Well, here we have an application where bituminous felt tape that's used in the waterproofing industry was used to wrap a special on a pipeline. And this landed up being a fairly major defect that had to be repaired. What had happened is that presumably the correct materials had run out. So quick trip to the hardware store and a couple of rolls of torch-on waterproofing tape, but unfortunately it didn't have what it takes to compete or meet the requirements of pipeline service.
That said, that was a bit of a slump, but tape wrapping does have many uses in the pipeline coatings industry, because when you choose the right tape, they can be fairly easily applied. They're rather conformable, so they can be used to applied to varying sizes of pipe and so on.
South Africa actually has a very good track record in the use of tapes, and this is somewhat contrary to international practice, where a lot of people are scared of tapes. But the tapes like this were used to wrap the original Durban-Johannesburg fuel pipelines. One of the best ways of applying tape to long pipelines is the use of what's called line wrapping, where this large contraption that's hooked up behind a side boom is both cleaning, priming, and wrapping the pipe in a single operation. And you can actually see in the photograph the various rolls of tape being applied, and immediately behind that, rolling spring holiday detection to ensure that the tape is being applied correctly. This machine is quite a monster. You can see there, that's the sock that is used to apply the primer. That's a butyl polyethylene laminate inner wrap. And these two large white rolls are of a heavy-duty polyethylene outer wrap. And in this case, the use of two rolls enabled the applicator to use what is a single wrap technique, and that applied effectively two layers of the outer wrap in a single pass, giving you the equivalent of the 55% overlap that we commonly use for the application of tapes. Even machines don't always get it right. If you don't set up the machine correctly, you'll end up with an offset in either the spiral or the tension or whatever, and you'll end up with these huge gaps in the tape where you can then get water ingress and the possibility of corrosion in spite of the presence of cathodic protection that might be on the pipe.
Isn't that called fish eyes or fish mouths or something?
Fish mouths, yes, because when these things are rather small, as opposed to this large one over here, it actually looks like the gaping mouth of a fish.
Right.
Tapes don't have to be applied by machine, because obviously if you're doing rehabilitation work, you can't get a machine into the trench. And here we can see a bituminous inner polyethylene outer being applied by hand on a pipe that's been excavated, cleaned, and primed with a suitable primer for this particular tape application. In another application, similar tape being used, you can see it's black on the inside, white on the outside. And this is a road crossing that is being prepared to be installed in a cut and cover operation, where the pipe was prepared prior to the excavation, and then the road was closed, the pipe was dropped into the trench, and the road was reopened again a few hours later. This particular operation was a butyl bitumen mastic inner and either a polymeric outer. I'm not sure whether this was polyethylene or PVC. And you would be hard pressed to say that this wasn't applied by machine. They did such a good job.
Yeah, that looks great. That tape is all in one direction. And I see here that this is two different directions.
Yes, this is what one would call a helical wrap as opposed to a spiral wrap, in that the inner wrap is applied in the one direction and the outer wrap in the opposite direction. And this has some mechanical advantages in terms of equalizing the stresses in the tape, but it does mean a double operation in order to achieve it. And at the end of the day, it is the decision of whoever is specifying the system how they are going to actually go about achieving the necessary thickness and integrity of the tape coating system.
But I see in that picture that even that application isn't perfect because there's a defect.
Yeah, that one over there. The tapes are not really resistant to mechanical damage. It is a challenge with tapes. And one of the reasons why some tapes fail is because they are not suitably backfilled with selected material. Those petroleum pipelines that we spoke about earlier, the owners at the time had a very, very stringent specification on selected fine sand padding that was put around the pipe. And that, together with good quality control during application, those tape-wrapped pipes are still in service today. One of the challenges with tapes, as with all the polyethylene, polyurethane, epoxy, all of these materials have similar electrical insulation properties. So if you even get a small defect, as you can see here, this is a little nick in a tape wrapping system caused by, in this case, it was sharp backfill because they did not use sand padding. And whilst that looks fairly innocuous, sitting underneath it was a significant level of bacterial corrosion. This particular pipe did not have cathodic protection on it, and the pipe was perforated within 2 years. It was a fuel line. The net result was the line was scrapped before it was ever commissioned due to this challenge.
Well, that immediately pushes up the price of the coating system. But Neil, there are lots of older pipelines that have been tape wrapped, lots of successful case histories. We've spoken about some of the sort of horror stories, but the pipes can perform really good service, even if they're tape wrapped.
Yeah, so this photograph actually is one of the fuel lines that was wrapped in the early 60s or 70s. And there's a good illustration of a fish mouth. This is only in the outer wrap, and the inner wrap was still intact. These pipes were exposed and evaluated and then rewrapped because the pipes had to be encapsulated or encased in microtunnels due to the construction of a heavy haulage roadway over the top of the pipes. Right. The pipes were not designed to carry heavy vehicle loads in direct contact, so they built massive culverts to control the mechanical forces. And there you can see this pipe here is 40 years old in absolutely pristine condition. There you can see some of the sand still hanging around after the pipes were exposed to be cleaned and rewrapped. And that rewrapping was then done in situ by hand with the pipes live and operational. So there's certainly a lot to be said for using tapes where the conditions are right.
And as long as the tension is maintained and the application is as per the specification, like all of the coatings we've talked about, they have their place and are very useful. I know one of the uses for tape wrapping with which most of the people here today are going to be most familiar will be with field joints. And if we think about field joints, we can see that it's a very practical, relatively easy to apply system, and also a little less stringent in terms of its surface preparation compared with some of the other coatings we've spoken about.
Provided the pipe has at some stage in its history been blast cleaned to remove mill scale, then wire brushing is an unacceptable surface preparation for most of the tape systems. And something that a lot of people don't realize is that ST2, which is the wire brushing standard, is actually a very stringent surface preparation standard in terms of the level of cleanliness that is achieved on the surface before application. And so because of the hoop stress in the tape as it's wrapped, whether that hoop stress is actually tension in the tape, or with the soft tapes like petrolatum tape, for example, it's not hoop stress, but just plain stickiness that keeps the tape in place. The chemical and mechanical bonding that we need with liquid coatings, like epoxies, polyurethanes, and so on, is not necessary. However, going back to the question of mechanical strength, the tape here is an example of the tape being used on a 3-layer polyethylene coated pipe. So there's now a huge difference in the mechanical damage resistance of the two systems, albeit they both have the same electrical and cathodic disbonding properties. And in order to overcome that, you've got two options. You can either import sand for every field joint. That's not something that construction contractors like the concept of. So in this situation, there is a mechanical rock shield that is being applied over the top of the tape wrap in order to protect it from the run of trench material that is used on the rest of the pipeline.
With that rock in the background, there's some mean run of trench material.
Yeah, right. We also need to remember that not all field joints are welded.
That is true. And when we have couplings of different sorts, we need to find another mechanism, and tapes can still be used. Mastics are fabulous in being able to fill up the nooks and crannies. And here you can see the application of the mastic, which can then be profiled to give us a smooth line along which we can apply the tape. And the nice thing about the mastics, of course, as well, is that they can accommodate the cathodic protection cables. So those you can see on the top of this joint that have been tied into the pipeline onto the flange itself. And those can also be coated with the mastic to create that smooth profile, wrapped with the tape. And then in this case, which is the petrolatum system, you cover it with, I always call it glad wrap, just with a clear plastic polyethylene sheeting. And you can see you've got a nicely formed surface with no big bulges or fish mouths or unevenness at all. And that will obviously also be quite good at withstanding some of the rigors of being a buried pipeline.
True, but these encapsulated joints are a prime candidate for sand. You have to have sand padding around that. You can imagine that if you were to just dump run-of-trench material on top of that coupling, that the rocks would deform, penetrate, and really make a mess of that very nicely finished corrosion protection system.
Just for anybody who hasn't ever encountered this petrolatum mastic system, if you think back to your childhood days of playing with plasticine, that's the kind of texture and consistency of the mastic. So as Neil says, it's really soft, and you can imagine a sharp stone easily penetrating that and causing damage. You're absolutely right, Neil.
This system has been around in excess of 80 years and is still used today.
You know, if it ain't broke, don't try and fix it. But the technology is also amazing, and there are new kids on the block. And I'd say the newest kid on the block in terms of tape wrappings are the viscoelastic products.
Yeah, here you can see a fabric-backed viscoelastic material being wrapped around a pipe in the form of a tape. And these tapes do not need tension. They rely on the adhesive properties of the viscoelastic compound to keep the tape in place on the pipeline surface. But they are soft, and they need to have some mechanical protection. Just like we were talking about yellow jacket pipes, where they had a polyethylene sheath over the top of a soft bitumen polymer compound. Well, in this case, you can use either a glass reinforced epoxy outer wrap, which provides a hard shell over the external of the viscoelastic, giving you the mechanical protection, with the viscoelastic underneath giving you corrosion protection. Or you can, in fact, use a spray-on polymeric system to achieve the same result.
And I think with both of those, it's worth mentioning that the advantage of the viscoelastic and in fact of the more old-fashioned bitumen-based tapes is that they've got that corrosion protection on the inner layer. And then that outer protection is really, I know it's a commercial name, but a rock shield, a protection against the environment. And if they've got that kind of protection over them, I suppose that adds to the cost, but the catch with all of the tape wrappings is to consider the backfill, the environment.
Absolutely. I think that is one of the aspects that's going to come out quite clearly tomorrow when we talk about coating selection, is that you don't only look at the cost of the material as applied, you have to look at the total cost. And the application of the viscoelastic material in this particular slide is a situation where the contractor chose to use the material for his field joints because of the simplicity of the operation. Here you can see the viscoelastic sticking out ever so slightly from the edge of the outer tape, which is either a polyethylene or a PVC, and that is providing your mechanical protection, again with the viscoelastic providing the corrosion protection on the inside.
I think Neil, you just made a comment there that is very appropriate within the South African context within which we find ourselves. A lot of the tape wrappings lend themselves to a fairly low skill application and low overhead application in terms of the field. And that's really useful where projects require a high utilization of labor to try and meet some of the unemployment challenges that we face. And tapes are ideally suited to that, but within that constraint, as you keep pointing to, and which we've had some horror stories related to, you just need to ensure that you've got appropriate backfill to protect them once they've been installed.
That is a mechanical reinforcement that was used by one of the water authorities to enable them to upgrade the pressure rating of a coupled pipeline.
Maybe the encapsulation might work with lots of profiling.
Sure, going to take a lot of material.
So I guess the bottom line is that not every application is tape suitable, but tapes definitely do have their place, and they have a very worthwhile place within the coatings industry, within the pipeline coating segment. I guess it would be appropriate to say that's a wrap, folks.